Hi, good day. I'm Arjun Desena, and this is my OJT report for the D.C.H. Reyes Structural Design Consultancy, or the David Carl H. Reyes Structural Design Consultancy. Now, first, let us look what are the contents of my PowerPoint presentation. Number one is the company profile. Second is the activities, engineering problem, and conclusion, and also recommendations. Now, first, let's discuss the company profile or the chapter one. For the company profile, D.C.H. Reyes Structural Design Consultancy is a structural engineering firm founded in 2011 and located at Madrigal Business Park, Alabang, Muntinlupa City. The firm is also known for its innovative and cost-effective structural solutions catering to residential, commercial, institutional, industrial, and mixed-use developments. They champion the philosophy of structural design aesthetics, ensuring structural integrity does not compromise but instead enhance architectural creativity. All through continuous collaborations with architects, developers, and also contractors, this firm has built a solid reputation for delivering safe, efficient, and visually pleasing structural designs. Their mission and philosophy uh, is to bridge the gap between structural stability and architectural expression. They strive to produce designs that are not only structurally sound and code compliant, but also aesthetically aligned with the client's vision. In a country like the Philippines, where budget limitations are common, their approach ensures optimal structural performance without overspending. Emphasize Emphasis is placed on design, flexibility, safety, and practical feasibility, creating balance in every project. Its principal engineer is Engineer David Carl H. Reyes. He was the founder of D.C.H. Reyes Structural Firm. He graduated from University of the Philippines, Diliman, with the degree of civil engineering. He was a licensed civil engineer with over a decade of experience in one of the top firms, T Squared Plus Associates Incorporated. Engineer Reyes has contributed to landmark projects such as U.S. Embassy expansion in Manila, Festival Mall Alabang expansion, Avaya Cove by Ayala Land, Robinson's Cybergate, and BPO Towers. In 2014, he established his own consultancy, now trusted in delivering complex and high-rise structural design nationwide. For its core services offered, of course, it offers structural design and for low, mid, high-rise building across various sectors, focusing on efficiency, code compliance, and coordination with architectural intent, structural investigation analysis, and of course, value engineering. They also focus on budget conscious alternatives for clients without sacrificing performance. They also offer structural retrofitting and restoration, specialized in restoring heritage and old buildings, ensuring extended usability and safety. Now, their technological capabilities, they uses advanced structural software such as ETABS and STAAD for 3D modeling and analysis. These tools provide accurate load simulation, detailed analysis and member behavior, and compliance with local and international building code. Integration of digital tools ensures data precision, efficiency, and responsiveness during design and analysis phase. Their commitment to quality upholds professional integrity and engineering excellence as its core value. They embrace modern technology and global trend to stay ahead of industry standard. They commit ref- reflects and successful delivery of safe, efficient, and architecturally aligned structures. Actively invest in continuous learning, collaboration, and innovation to remain competitive in structural design field. For their select major projects, they have residential, commercial, institutional healthcare, office buildings, and hotels, and of course, resorts. Now, for the training activities, which is the chapter 2, the first one is the orientation and lecture. Now, in orientation and lecture, the training begins with an orientation session led by the head engineer, which also introduced interns the company's structural workflow, office culture, and expectation. For key concepts such as load-bearing systems, structural safety, and role of design computation were explained, setting a strong foundation for upcoming technical tasks. Lectures covered core structural principles, including slab behavior, shear stud, and composite construction system. Practical session includes the design of RC slab on metal deck, which emphasize compatibility between materials, decks, and load distribution or efficiency. Interns were also introduced to structural design softwares such as TAAD and ETABS and trained in using Microsoft Excel for code-based calculation, improving both technical literacy and real-world application skills. For the reviews and checking, interns were tasked. We are tasked to review structural members like beams, slab, and column for accuracy and reinforcement, details, and dimensional conformity. Activities included cross-checking drawings with plan schedules, verifying consistency and annotations, and spotting discrepancy in layouts. Emphasize, Emphasis was placed on precision and attention to detail, ensuring all drawings match and firm standards before being issued to client or for construction. Other tasks includes reviewing schematic diagrams, scaling issues, and spacing of rebars, which are essential to avoid miscommunication on construction site. These tasks enhance the intern's ability to interpret and evaluate structural documents with engineering accuracy. For drafting, a major focus on the training was on creating detailed structural drawings using AutoCAD. We worked on various components, including staircase, swimming pools, retaining walls, septic tank, and cistern, learning how each fits within a building structural system. Task includes dimensioning, scaling, and interpreting architectural inputs to produce accurate and buildable drawings. Revision of existing drawings, especially for retrofitting projects like a Pan Casino project, one of our project that are taught interns how to adapt existing structures for enhanced strength and safety. Exposure to foundation plans, roof framing layouts, and structural revisions provide insights into how initial schematic evolves into final engineering plans. There are also meetings and a site inspection. Interns were invited to attend project coordination meetings involving engineers, architects, and also the clients, observing how design decisions are debated and resolved. Topic discussed includes beam height conflicts, slab level adjustment, and column relocation, helping interns understand a real-world implication for structural decision. Site visit gave intern first-hand exposure to rebar inspections, concrete pouring procedures, and compliance checking, reinforcing the importance of translating plans into actual build. During the CPR or the concrete pouring request site inspection, interns help verify bar spacing, sizes, and placement accuracy compared to design specification. Regular interns meeting taught interns about project management, task allocation, and team communication, showing non-technical side of engineering operation. Now let's move on to the engineering problem or the chapter 3. Here we would discuss about the engineering problem that I had encountered. For the introduction, the chapter focuses on the real-world engineering issues encountered during the OJT recruiting, conflicts between structural design requirements and architectural intent. These conflicts are not simply technical but interdisciplinary in nature, requiring collaboration between engineers and architects to resolve. Example includes scenarios where structural beams obstruct window placement or where large column reduce usable space affecting the aesthetics and functionality of a design such issues highlights how important communication, flexibility, and coordination are in real-world projects. For the objective of this study, it is to identify and analyze a common structural design problem encountered during the OJT experience, examine the root cause of design conflicts, particularly between architectural and structural teams, understand how this issue impacts project timelines, revisions, and coordination, to explore methods of resolving such conflicts, and to reflect on how participation in professional design discussion helps improve problem solving and decision making. For its significance of the study, the issue reflects a real challenge in structural engineering practice, how to balance creative architectural concept and structural safety and feasibility. It emphasized the needs for early interdisciplinary collaboration during the plant and design stage. By understanding how design changes affects both discipline, engineers, and become more adaptable, responsible, and holistic thinkers. For students and trainees, addressing such conflicts promotes professional growth as they learn to work with other teams rather than isolation. Discussion of engineering problem. During the OJT, multiple projects revealed misaligned alignments between structural and architectural elements, especially with beam placements affecting window heights or ceiling clearance. One specific example involved a beam interfering with full height window layouts to meet aesthetic goals. In other cases, flat slab system led to interior spacing clearance issues from a redesign of certain areas. These incidents caused delay, reworks, and extended coordination, underscoring the importance of catching such issues early in the design process. Now, for the possible solution to this problem, it is important to conduct early coordination meetings involving both structural engineers and architects before developing detailed designs. Implement design review checkpoints at various projects stage to catch potential conflicts before they escalate. Use 3D modeling and building information softwares to visualize and detect clashes in real time. Develop flexible structural and alternatives such as shadow beams, cantilever section, or hidden beams when needed. Maintaining open communication channels throughout the project to allow quick issue resolution and minimize disruption. Documents all decision and revision during meeting to ensure accountability and reference for future updates. Also involve junior engineers and intern in this process to broaden their understanding of real-world coordination. Lastly is to establish standard office procedures that require structural consideration to be weighed against structural input from outset. For the conclusion, this problem shows that engineering is not just numbers and analysis, but also about people, vision, and compromise. The conflict between structural and architectural design requirements taught us the importance of being flexible, communicative, and open to solution. Resolving these issues required teamwork, respect for each discipline's goal, and a willingness to adjust and adapt. The experience reinforced that uh, real-world engineering problems are multidimensional, involving both technical expertise and interpersonal skills. Technical and soft skills learned first is the technical skills, interpreting and revising structural and architectural drawing. Also, we applying AutoCAD to adjust layout based on a real-world issues. Participating in design revisions and understand plan impacts. Also using reference and standards to validate solutions. For software skills, communicating design concern in meeting with other disciplines, adapting to feedback, and learning how to defend or adjust proposals professionally. Also develop teamworks and negotiable abilities and enhance decision making under pressure and real project constraints. Lastly, for the conclusion and recommendation, which is the chapter 4. Now, for the conclusion, for my OJT experience, real-world tasks help in applying civil engineering theories to actual projects, from planning and designing to coordination and site inspection. It also we realize that engineering is not just about calculations, but also about communications, collaboration, and practical decision making. For the challenges that we encountered and lessons learned, faced challenges such as tight deadlines, design conflicts, and pressure of real-time revision. Also, we learn how to manage tasks under pressure, stay organized, and respond constructively to feedback. We also develop resilience, adaptability, and proactive mindset, which are essential in any engineering career. Now, for the growth in technical skill uh, and soft skill, we gain value skills in AutoCAD drafting, plan checking, specification writing, and use of tool like STAAD and ETABS. Strengthen professional skills like teamwork, communication, time management, and taking initiative. For the recommendation, for of course, for the future interns, they should embrace every opportunity, be open learning, and actively ask questions. It is also important to pay attention to both technical details and interpersonal dynamics during training. Students are encouraged to observe site practices, attend coordination meetings, and learn beyond the desk work. For the OJT programs and companies, training programs should continue to expose students to a mix of office-based and field experiences. Structural firms are encouraged to invest in mentoring, provide clear instructions, and offer constructive feedback to help trainee grow. Thoughts and professional aspiration. The OJT experience confirms that we are passion for civil engineering and aspired great motivation to pursue this career. The training journey helps builds confidence and the in we prepare we to prepare the interns for more responsibilities in the future workplace. So thank you, and this is Arjun Desena from D.C.H. Reyes Structural Design.